Do you want to learn how modern APIs are built using Node.js and its related technologies? Then this video is for you. We are going to build a simple but robust application packed with tons of explanation and real-world experience on how modern backends are built. We're going to build a blog API that has authentication and also the ability to upload an image. This is going to be a fun and incredible journey. We will be using tools like Swagger for our documentation presentation. Express.js is a web application framework for Node.js designed for building web applications and APIs. MongoDB is a NoSQL database that uses a flexible document-based data model. NodeMon is a utility that automatically restarts the server whenever file changes are detected. Mongoose is an object data modeling library for MongoDB, and Node.js, providing a structured schema for your data. Bcrypt is a library used for hashing passwords to securely store them. JSON Web Token is a standard for creating tokens that allow for the secure transmission of information between parties. testSpirit is a popular tool for API testing and development. If this sounds fun, stay with me and let's learn together. According to YouTube Analytics, most of you who watch my videos are not subscribed yet. Please consider subscribing and hitting the like button. I am excited to introduce my first software as a service project called I Built This. I Built This is built for developers who want to escape tutorial hell. Learning to code is just one piece of the puzzle. You need real projects with real teams. I Built This is about quality, hands-on projects. We have a couple of projects on the platform which have AI recommendations based on your interests and learning goals, which you inputted during onboarding. The projects are also categorized into different fields. We have web dev, mobile dev, AI and machine learning, and gaming. We have a couple of daily and weekly challenges you can have your hands on to practice and improve your coding skills. This project is one of the ones I built a couple of months ago, so I will click on it and build it with the help of I Built This. After joining the project, we set it up and then start building. On the task page, we can use AI to generate tasks, and if they're good, we assign them to ourselves. So I will assign a couple of tasks to myself and click on the Complete Setup button. Then we move to the project details page. On this page, we have the project progress, the tasks, and we can update the project settings, like the project timeline and other features. So let's add a new milestone to the project by clicking on the project settings button. On this modal, we add a title and due date for the timeline and save it. And we have it here. On the task page, we have all these statuses which you can drag to a different state based on the current task you're working on to keep track of your progress. Let's talk about challenges. On the challenges page, let's say I am interested in this challenge called longest substring without repeating characters, and choose to join this challenge using the Join Challenge button. Now upon joining, we are taken to the dashboard. On this dashboard, we can work on the challenge in real time with our inline code editor. If your code satisfies all the test cases, you can publish it for others to have a look or get inspired by your solution. Not only can you work on the coding challenges, but you can also work on the design challenges. These challenges give you access to code and allow you to see changes in real time. As you can see on the dashboard right now, you have the ability to toggle between the design you are building and what you have built so far. If you are satisfied with your solution, you hit the publish button and you are good to go. You can also save your code and continue later anytime you are ready. On the dashboard, we have the chat feature for projects that need more than 2 teams. Everyone gets the message, it broadcasts to everyone. On the project metrics section, we have your total projects, challenges, total activities, and contribution scores. This is a project that will genuinely change the way beginners and even professional software engineers enhance their skills. If this sounds amazing, kindly visit ibuildthis.com and start working on a project now. Follow us on socials, on Twitter, TikTok, and YouTube. Links are provided in the description. We're going to break down the key components of a modern backend API. We'll use this diagram as our guide to understand how all the different pieces fit together, from the tools we use to the final product we serve. First, let's look at the foundational building blocks, our core tools. These are the essential technologies you'll use to build the entire system. We're talking about Node.js, which is the runtime environment that lets us execute JavaScript on our server. We also have TypeScript, which adds static typing to our code. This helps us catch errors early and makes our code base more robust and easier to manage. Then there's Swagger, a fantastic tool for documenting and testing our API. And finally, NPM, our package manager, which lets us easily install all the third-party libraries we need. Now let's look at the heart of the system, the back-end components. At the top, we have our API. This is the entry point for all incoming requests from clients like a web browser or a mobile app. When a request comes in, the first thing it does is interact with our database. The database is where all of our application's data lives, so the API needs to talk to it to get, save, or update information. Next, we have a crucial security component, authentication. This block represents the gatekeeper for our API. It ensures that any user trying to access protected data is who they say they are. All requests must pass this security check. And finally, we have the business logic. This is the brains of our application. It's where we write all our custom code to handle things like user registration, creating a blog post, or any other core task. The last part of our diagram shows the different ways our backend can serve data to a client. The most common type is a REST API. This is a well-established architectural style that uses standard HTTP methods like GET, POST, and DELETE to perform actions on resources. But we also have a more modern approach, a GraphQL API. This is a query language that lets the client ask for exactly the data they need. It's often more efficient because it prevents us from sending too much or too little data to the client. And that's the big picture. We start with our core tools, which we use to build our backend components, which in turn serve data through our API. Understanding this flow is key to building any modern web application. For this project, we are going to use TypeScript, so we need to install it. But before that, what is TypeScript and why are we using it in this project? TypeScript is a superset of JavaScript that adds static typing. This is incredibly important for catching errors before your code even runs, which is a major advantage for large teams and complex projects. While both JavaScript and TypeScript have similar performance, TypeScript's focus on code quality and reliability makes it a better option for a scalable, maintainable application. Although it has a slightly steeper learning curve, the long-term benefits in code stability and developer experience are worth it. Now, download and install your favorite code editor. Here, I'm using Cursor AI, which is more like VS Code on steroids, with all these AI-powered features to generate code, debug, and make the whole coding process entirely easy and smooth. Check the description to download it. After installing it, create a project directory or folder. Over here, I have mine named Backend Course. You can choose to name yours Blog API, since this project is all about building a blog API. Hitting Ctrl+tilde opens our terminal window. Over here, we are going to start with a step-by-step way to set up your environment and begin with your first server-side code and your first API. Using npm init-y, you initialize a new Node.js project and create a package.json file without having to answer any prompts. It uses default values for everything. Now, after installing, we get a package.json file. In this file, we have a basic setup. The name is the name of our project. The version is the current version number. Main indicates the entry point of our application. The scripts section allows us to define and run command line tasks for our project. And keywords, author, and license provide metadata about our project. So to install TypeScript and get all the advantages, we install it this way. npm install -d TypeScript at types/node.ts-node. Now, when we check the package.json file, we can see that in the dev dependencies section, we have our TypeScript added, verifying that we have indeed installed TypeScript. So next, let's create a file called t-s-config.json. This file is the configuration file for the TypeScript compiler. It tells the compiler how to transform your TypeScript code into plain JavaScript. We are going to have this code inside the tsconfig, which you can also see in the GitHub repo for this project. This configuration specifies how the TypeScript compiler should behave. Now, we are going to create our first vanilla server using just pure TypeScript with no external packages. First, we are going to create an src folder. An src folder is a standard convention in software projects used to store all of your source code. It keeps the main application file separate from configuration files or other project assets. Inside this folder, we are going to create a new file called index.ts. This file will be the entry point to our backend and API, which means that when we call or run our application, it will start here and get access to all the routes and everything else in our app. You will get to understand this as we build the app. Inside the index file, we will create our first HTTP server. So we are going to import HTTP from the core module inside Node.js. The HTTP module provides the core functionality to create HTTP servers and clients, allowing us to handle requests and responses without needing any third-party libraries. Then we create a constant called server and set it equal to create server. Which takes two callback arguments, request and response. The request object contains all the information about the incoming request, such as the URL and headers. The response object is what we use to send data back to the client. Inside this piece of code, we are going to set the headers so browsers can correctly interpret our response. We do this by typing res.setHeader with the arguments content type and application/JSON. This tells the browser that the data we are sending back is in the JSON format, which ensures it displays correctly. Next, we handle the request by checking if the incoming request URL equals a /. We will do res.writehead with the number 200, which is the HTTP status code for a successful request. Then we call res.end with the argument json.stringify of an object that contains a message property with the value hello world. This sends the final response to the client, converting our JSON object into a string. The end method also signals that the server has finished sending its response for this particular request. Then we listen to the server using this method, server.listen with the number 3000 as the port and the callback function. This command starts the server and makes it listen for incoming connections on port 3000. The callback function then executes once the server is successfully started. After the server is listening, we can add anything to the callback function, such as a message to the console or even a function to connect to our database. Now let's save the file and move back to the package.json file. Inside here, we are going to modify the scripts to be able to run our application. So we will add 3 new scripts. The first script is dev in double quotes, followed by a colon, and then ts-node src/index.ts in double quotes. This dev script uses ts-node to run our TypeScript file directly without needing to compile it first, which is great for development. The next script is build in double quotes, followed by a colon, and then tsc in double quotes. This build script uses the TypeScript compiler tsc to compile our TypeScript code into standard JavaScript. Finally, we have the start script followed by a colon, and then node.dist/index.js in double quotes. This start script runs the compiled JavaScript code from the dist folder using node.js. Now in the terminal, we type npm run dev, and we can see that our server is running on port 3000. This is excellent and awesome. Now when we navigate to our browser and type localhost:3000, we get a file downloaded for us. And when we open that file, we get to see the message we instructed our server to send when a user hits that /URL, which is basically the root URL. With just that, you have built your first HTTP server without using any external packages by just using the Node.js HTTP module. Congratulations on this one. Now, let's get rid of everything inside the index file and start writing an efficient, secure, and modern backend using a framework. We will be using express.js. Express.js is a minimalist and flexible Node.js web application framework that provides a robust set of features to develop web and mobile applications as well as APIs. We will be following the setup code on the express.js website. Let's go ahead and click on the Getting Started item on the navbar. Over here is the installation procedure. We already have our folder created and most of this done. Let's go ahead and install Express using the command here. Let's copy it, move back to the terminal, close the running process, use the clear command to clean the terminal, and paste the install code for express.js. We will wait for a while for it to get finished. Back on the website, we will click on the next Hello World link and continue with the setup. Over here is a Hello World example. Back in the index file, we will import Express from the Express package. And now we will create a constant called app and assign it the value of Express with 2 parentheses. This line of code initializes an Express application and it is the foundation of your server. Here's this red wavy line under the Express package, which suggests that we install types for it. A type is a separate file that provides a set of definitions for a JavaScript library, allowing TypeScript to understand the shapes and structures of the library's functions and objects. This gives us better code completion and error checking. So let's install that now. Back to the Express website. We would have to create a port to run our app. So we create a variable called port and assign our port number 3000 to it. Next, we create a function to listen to the port. We will type app.listen, which accepts a callback. For now, we will just log a message to the console. We will edit the log message to add the URL, so http://localhost:/port. Now we can run npm run dev, and inside our terminal we can see the log message. Server is running on port at http://localhost:3000. And finally, let's add the last piece of code from the Express website. We have app.get, which takes a / in double quotes as the first argument. The get method defines a route that responds to HTTP requests at the specified path, which in this case is the root URL. The second argument is a callback function with rec and res parameters. Inside the function, we have res.send with the string hello world. This method sends an HTTP response. Let's open the port on port 3000 on the browser. And we cannot get the home root, which means there is something wrong. Let's go through the code and try and fix things. Let's first change the res.send of hello world into this. We will type response.status and pass in 200 as an argument, .json, and return the message hello world inside of an object. The res.status method sets the HTTP status code for the response, and the JSON method sends a JSON formatted response to the client. Using these two methods together is a professional and common way to send a complete API response. We are still seeing cannot get / at the URL. The next thing is to stop the process and restart it again. Pressing Ctrl+C stops the process. And let's run npm run dev again. Here we get an error saying rec is declared but its value is never read. So to fix this, let's move to our tsconfig file and change this property. Inside here, we will change the property of no unused parameters from true to false and run the npm run dev again. Now let's refresh the browser and we can now get the message hello world. Looking good and great so far. Now, have you noticed that anytime we make a change to the code, we have to manually stop the process using Ctrl+C and then use the npm run dev command to start it all over again? This isn't the ideal way of building a complex API or backend server. So we will install a tool called NodeMon. It's a utility that automatically restarts your Node server whenever it detects changes to your project files. This saves a lot of time and effort by eliminating the need for manual restarts during development. So let's copy the installation command from the NodeMon website and paste it inside our terminal. There is an error, and we are going to copy the error and give it to the cursor AI chat dialog. By pressing Command+I on your keyboard, the chat dialog opens. We sit back and wait for the AI to perform its magic. So from the dialog of the cursor editor, we can see we needed to change the installation command using -d. The -d flag is short for --save dev, which saves the package as a development dependency in your package.json file. This means the package is only needed for development, not for the final production code. The AI also updated the dev script to make sure NodeMon is working and running on save. The command nodemon watch srcn xts, jsh backslash quote ts hyphen node src slash index.ts backslash quote is a full command line for NodeMon. The hyphen watch flag tells NodeMon to watch the src folder for changes. The hyphen ext flag specifies which file extensions to watch for, in this case, TypeScript and JavaScript files. The hyphen exec flag tells NodeMon the command to execute when a file changes, which is to run our server using ts-node. These are really useful and help us fix issues and errors really quick without having to toggle to Googling and all that. So I will go ahead and keep this code and run the npm run dev command again to start everything again. Now we can see we have NodeMon watching changes, and as soon as a change happens, it refreshes, so we don't have to do that manually. The Model View Controller, or MVC architectural pattern, is a widely used design approach for building applications. This diagram shows how three interconnected components work together to handle a user request and present a response. The process begins when an end user sends a request to the application. This request is first received by the controller. The controller's job is to manage the flow of the request. It acts as a go-between, deciding what needs to be done. The controller handles the request flow but never handles data logic. Based on the request, the controller instructs the model to fetch data. The model handles the application's data logic and interacts directly with the database to retrieve or store information. Once the model has the necessary data, it sends it back to the controller. The controller then directs the view to fetch a presentation. The view's primary responsibility is to handle data presentation. It takes the data provided by the controller and renders it into a user-friendly format, such as a web page or a JSON response. The view is dynamically rendered. Finally, the complete response is sent back to the end user. So let's create these folders inside our src directory, starting with controllers, middlewares, models, routes, and config. This is going to be our standard layout, and it's an industry standard way of organizing your workspace. The controllers folder is for the functions that handle incoming requests. The middlewares folder holds functions that process requests before they reach the controller. The models folder contains the schema definitions for our database, representing our data. The routes folder defines the URL paths for our API endpoints. And finally, the config folder is for all our application's configuration files, like the database connection. So let's begin with setting up our database with MongoDB. We will create a new file inside the config directory, database.ts. Literally, inside here is going to be the code for connecting our database. MongoDB is a NoSQL document-based database that stores data in flexible, JSON-like documents. It is excellent for building modern applications that need a flexible schema. So on the main page of the MongoDB website, we are going to click on the Get Started button. It will immediately take us to the register page. Register and follow along. On this page, we will accept the privacy policy and terms of service and submit. Next, we will create a cluster. We have a couple of tiers and we are interested in the free tier. We are going to leave the cluster name unchanged and leave all the other options unchanged. And then we are going to create the deployment. We are going to create a database user and choose a connection method. Over here, we are going to connect our app through the drivers method. When we scroll down to the add your connection string into your application code section, we will copy the URL string and move back to our code. Create a .env.file mongodb underscore URL variable and paste the string we copied. Back to our MongoDB dashboard, click on Done. Now, one more thing. Under the Security tab, we select the network access and edit it to allow access from anywhere. We are doing this for the sake of this tutorial to make it easier to connect from any machine, but in a real-world application, you would restrict this to only the IP addresses of your servers for security. Hit on that confirm button and that will be it. Now, inside the database file, we are going to use Mongoose. Mongoose is an object data modeling or ODM library for mongo.db and Node.js. It provides a structured way to interact with our database by giving us a schema-based solution for our data. We will copy the installation command and paste it inside our terminal for it to install. Once done, we will start with an import statement for the Mongoose library. So we type import mongoose from mongoose and hit enter. Next, we'll export a constant variable, which will be our main function for connecting to the database. We'll call it connectDB. It's an async function and it returns a promise less than void greater than, which just means it's an asynchronous operation that doesn't return a value. Let's type out export const connectDB equals async parentheses colon promise less than void greater than equals greater than curly brace and then a new line. Inside our function, we'll start with a try block. This is where the code we want to execute goes, and it allows us to catch any potential errors without crashing the application. So we'll type try curly brace and hit enter again. On the next line, we'll declare a constant variable called mongo URI. We'll get its value from our environment variables, which is a secure way to store things like database URL. We access it using process.env. So type const mongo URI equals process.env square bracket double quote mongodb underscore URL double quote square bracket. Now we need to make sure that variable actually exists. We'll add an if statement to check if mongo URI is not defined. If it's not, we'll throw a new error with a clear message. So we'll type if parentheses exclamation mark mongo URI parentheses curly brace on the next line, then throw new error parentheses double quote. MongoDB underscore URL is not defined in the environment. Variables double quote parentheses and close the curly brace. The next line is the most important one. We're going to await the mongoose.connect method, passing in our mongo URI. This is the action that actually connects us to MongoDB. Type await mongoose.connect parentheses mongo URI parentheses semicolon. we're going to add a little extra robustness here. We'll set up an event listener to handle a clean shutdown. We'll listen for the SIGNT signal, which is sent when you press Ctrl plus C. Inside the listener, we'll await mongoose.connection.close to disconnect from the database, then process.exit with the number 0 to exit the application cleanly. To finish up our try block, we add the closing curly brace. Now we add a catch block to handle any errors. If the try block fails for any reason, the code will jump here. We'll just throw a new error that includes the original error message for easy debugging. Alright, let's move on to the code for disconnecting from the database. It's just as important to have a clean shutdown as it is to have a clean connection. We'll start by exporting a constant called disconnectDB, which is another async function. This one doesn't take any arguments. The promise is just TypeScript telling us it's an asynchronous function that won't return anything. Try curly brace. Just like with our connection function, we'll open a try block. It's always a good idea to put your database operations inside a try catch to handle any errors. Await mongoose.connection.close parenthesis. This is the core of our disconnect function. We use await mongoose.connection.close to terminate the connection to our MongoDB database. Mongoose handles this gracefully for us, making sure any pending operations are completed before the connection is closed. We'll close the try block with a curly brace, and that's it. A simple but crucial function for a clean and reliable shutdown of our database connection. This code ensures our application tidies up after itself. Now, inside the models directory, we are going to create two new files called blog and user. And we will start working on the user model. Alright, let's start creating our Mongoose user schema. This code will define the structure of our user documents in mongo.db. First, we'll import Mongoose itself, along with a few important types from it: schema, document, and model. We'll use these to ensure our code is strongly typed with TypeScript. Now, we'll export an interface called iUser. Interfaces in TypeScript are crucial because they define the shape of our data. We're extending the Mongoose document type to get all of its built-in properties, like the _ID. Inside our interface, we'll define the fields a user document will have. We'll add a name, email, and a password hash, all as string types. We also include created at and updated at, which are date types. The last two are important for tracking when a document was created and last modified. Next, let's create our user schema. This is a new Mongoose schema object, which is what actually defines the structure and validation rules for our data. We pass in our iUser interface to tell TypeScript exactly what this schema should look like. Inside our schema object, we'll define the rules for each field. For name, we specify it's a string, it's required, and we use trim::true to automatically remove any leading or trailing white space. For email, we also make it a string and required, but we add unique::true to ensure no two users can have the same email. We also make it lowercase for consistency and index::true for faster lookups. Finally, our password hash is just a string and is required. Then, at the very end of our schema definition, we add curly brace timestamps, :true curly brace. This is a great Mongoose option that automatically handles our created at and updated at fields for us. Now that we have our schema, we can create our user model. This is what Mongoose uses to interact with the database. We call mongoose.model and pass it two things: the name of our collection, which will be user, and our user schema. We export this so we can use it in other parts of our application to query and save user data. Finally, we'll export user as the default export of this file. This is a common practice that makes it a little cleaner when importing this model into other files. And there you have it, a complete and robust user schema for our application using TypeScript and Mongoose to ensure data integrity and consistency. Next, we are going to create the auth controller file to communicate with the model and have our business logic. Let's move on to the core of our authentication system, the register and login functions. This file will handle taking user data, validating it, and securing it before interacting with our database. First, we'll import some types from Express. This isn't code that runs in our application, but is crucial for TypeScript to give us smart suggestions and type checking for our request and response objects. Next, we import our dependencies. bcrypt will be used to hash our users' passwords, making sure they're never stored in plain text. So we are going to install bcrypt by searching it on Google and copying the installation command from npm. Paste it inside our terminal and install it. JWT stands for JSON Web Token, and we'll use it to create secure tokens for our users. We are also going to install JSON Web Token by searching it on Google and copying the installation command from npm. Paste it inside our terminal and install it. And finally, we import the user model we just created so we can interact with our users collection in the database. We'll create an exported asynchronous function called register. it takes the standard request and response objects from Express. Because this function needs to wait for database and hashing operations, it must be async. As always with operations that can fail, we'll wrap our logic in a try block to catch any potential errors. We'll destructure the name, email, and password directly from the request body. The as curly brace part is a TypeScript feature called typecasting, which tells TypeScript what the shape of the request body should be. Here, we add our first validation check. If any of the required fields are missing, we immediately return a 400 bad request response with an error message. Next, we search the database for a user with the same email. We use await because this is a database call. If we find an existing user, we send a 409 conflict status, preventing duplicate accounts. Now for the security. We use bcrypt.hash to create a hash of the user's password. With 10 being the salt rounds for security. Once we have the hash, we use our user model to create a new document in the database with the user's name, email, and the new hashed password. With our user created, we can generate a JSON web token. We use jwt.sign and pass it a payload object, which contains the user's ID. We also pass a secret key, which you should get from your environment variables, and set an expiration date of 7 days. So let's create jwt_secret in our .env.file. The secret can be anything, as long as it's not easy to guess. If everything worked, we send back a successful 201 created response. The response body includes the new token and the simplified user object with their ID, name, and email. We convert the underscore ID to a string since it's an object in Mongoose. Finally, Our catch block handles any unexpected errors. If something goes wrong, like a database connection issue, we send back a 500 internal server error. Now it seems there is an error with the JWT secret, so let's fix it in chat. And we are good to go, all done by Cursor AI without any hassle. Bcrypt and JSON Web Token have a red wavy line. This is because we are missing the types, so we will install all the types for them. Watch and follow along. Now let's move on to the login function. This function will handle authenticating existing users. We'll start with a try block and then do the same thing as before. Destructure the email and password from the request body. And validate that they are present. We find the user in the database by their email. If no user is found, we send a 401 unauthorized response, indicating a failed login attempt. This is the most critical part of the login process. We use bcrypt.compare to compare the plain text password from the request with the stored hashed password. Bcrypt handles the salting and hashing automatically. If they don't match, we return another 401 unauthorized response. If both checks pass, the user is authenticated. We now generate and sign a new JSON Web Token, just like in our register function, to give the user a session token. We return a successful 200 OK response with the new token and a simplified user object. Since this is the default success status, we don't need to specify errors.status with the number 200. And finally, we have our catch block to handle any unexpected errors, sending a generic 500 message to the client. To wrap it all up, we'll export our two functions as the default export from this file. Before we continue with the app, let's create a new file inside the config folder called swagger.ts. It's one important package used in modern API design. Swagger provides a framework for describing and documenting your APIs in a standard format, which allows developers and tools to easily understand and interact with them without needing to read your code. This file acts as the configuration for our documentation, telling Swagger all about our API. First, we'll import the Swagger.js doc library. This is the tool that will read our comments from our root files and generate the Open API specification for us. Next, we'll create a constant variable called options. This is a configuration object that will pass to Swagger.js doc. Inside our options object, we'll create a definition key. Before we continue with the Swagger.js doc options, let's install Swagger from npm by copying the installation command and pasting it in our terminal. The first part is Open API with the string 3.0.0, which specifies that we are using version 3 of the Open API standard. Then under info, we provide some basic details about our API, like the title, version, and a simple description. Now we'll define our servers. This is a list of URLs where our API can be accessed. For now, we'll just add our local development server at http://localhost:3000. Next is the components section where we can define reusable parts of our API. We'll set up a security schemes component. We'll call ours bearer auth, and it's for handling authentication. We specify its type is HTTP, its scheme is bearer for a bearer token, and the bearer format is JWT since we are using JSON web tokens. This security section is crucial. By adding our bearer auth scheme here, we are telling Swagger that all of our API endpoints require a bearer token by default, unless we specify otherwise. This saves us from having to add a security tag to every single route. We'll close off our definition block and add one more key to our options. APIs. This is an array of file paths. We're telling Swagger.js doc to look in our src/routes directory for any file ending in .ts that might contain our API documentation comments. Finally, we'll call the swagger.js doc function and pass in our options object. The function returns the complete Open API specification, which will export as a constant called Swagger spec. And just to make it easier to import, we'll also export our Swagger spec as the default export of this file. Now we are done with the Swagger setup. Let's create a new file inside our routes folder called authroutes.ts file. We're going to create our router file. This file acts like a roadmap for our API, directing incoming requests to the correct functions. We'll set up our routes first and then add the documentation. First, we'll import the router from the Express library. This gives us the tool to create our API route. We also import our register and login functions from our auth controllers file. Next, we'll create a new router instance by calling router with parentheses. We'll assign it to a constant. Now, we'll create our actual API endpoint. We'll use the router object to map a URL path to a specific function. We'll start with the register route. We'll call the post method on our router to handle a post request, and we'll connect it to our register function. We'll do the same thing for our login endpoint, connecting the path /login to our login function. Our routes are functional, but we need to document them so other developers and our Swagger UI know what they do. We'll add JSDoc comments right above each route to provide that documentation. First, for our register route, we'll open a multi-line JSDoc comment. we start with the @open API tag to tell Swagger.js doc to pay attention to this block. Then we define the path /API/auth/register and the method post. Now we'll add some metadata. We'll add a summary to describe the endpoint and a tags property to group it under auth in our documentation. We'll describe the data this endpoint requires. We'll use request body to specify that the request body is required and that it should be in application/JSON format. We then define a schema with the properties for name, email, and password. Finally, we'll document the possible responses the API can return, along with a brief description for each status code, like 201 for a successful creation or 409 for a conflict. Now, we'll repeat this process for our login route, adding the same kind of documentation, but this time for the email and password fields and for the specific responses we can expect from this endpoint. Lastly, we export our router as the default export from this file, so it can be used in our main application file. Now, when we save this code and refresh our endpoint URL, nothing happens. So, back to our index.ts file, we are going to set up the endpoint for the auth and add a couple of configurations. We will start by importing .env. .env is a zero dependency module that loads environment variables from a .env file into process.env. And then we will configure it using .env.config with parentheses. We obviously have to install .env, so we use the command npmi.env. Next, we are going to get rid of the app.get root endpoint and start writing an endpoint for the API docs. Let's add a single powerful line of code to our main express file. This is the magic line that ties everything together and lets us see our documentation in the browser. We will type app.use with the arguments /docs . We need to import the Swagger UI, install it using npm, and import Swagger spec from the config file we created in the config directory. We need to install the type as well. Its job is to serve the static HTML, CSS, and JavaScript files that make up the Swagger UI webpage. Think of it like a static file server, but just for the documentation. Swagger UI.serve and Swagger UI.setup with Swagger spec. We'll use app.use to register middleware for a specific path. The first argument /docs is the URL path where our API documentation will be accessible. For example, if your app runs on localhost:3000, your docs will be at http://localhost:3000/docs. The second argument, Swagger UI.serve, is a middleware function provided by the Swagger UI Express library. The third argument, Swagger UI.setup with Swagger spec, is the final piece. It's another middleware function that configures the Swagger UI. We pass our Swagger spec object, which contains all of our API as metadata and endpoint definitions, to the setup function. It takes that specification and injects it into the Swagger UI page. making our interactive documentation visible and ready to use. In short, this one line of code sets up a new route, serves the Swagger UI web page, and then fills that page with the custom documentation we've defined in our Swagger spec. Next, we use app.use to register middleware just like we did for our documentation. The first argument /API/auth is a base path. This tells Express that any request beginning with this path should be handled by the middleware that follows. The second argument, authRoutes, is the router we created in our authRoutes file. Let's import that. By passing this here, we're telling Express to use our authRoutes router to handle all incoming requests that match the base path. This means that when a request comes in for a path like /API/auth/register, Express will automatically use the authRoutes router to find the correct handler function. This pattern is crucial for organizing your application. It keeps your routes modular and clean, allowing you to manage different parts of your API, like authentication, in separate files. Back at the connect database function, inside the database config file, we will import and call it inside the index file to establish a connection. We start by calling our connectDB function, which we know is asynchronous and returns a promise. We don't use await here because we're not inside an async function. Instead, we directly chain the .catch method onto the promise returned by connectDB. This is a built-in promise method that is executed only if the promise is rejected, meaning the connectDB function threw an error. The error is then passed as an argument to the callback function inside the catch. Now, when we move to our browser and use the endpoint/docs, we can automatically see our Swagger has given us a clean documentation already for registering a user and also logging in a user. When we expand on the endpoint, we see the example schemas, responses, and other details. We need to add a couple of configurations before we can test our API on the Swagger page. When building a web server with express.js, it's common to handle data sent from a client, such as a web browser or a mobile app. The app.use with express.json and two parentheses is middleware that passes incoming JSON data, making it available for use in your route handlers. When a client sends a request with the content type header set to application/JSON, the data is transmitted as a raw JSON string. Without this middleware, the rec.body property in your Express route handlers would be undefined. By adding app.use with express.json and two parentheses, you're telling Express to process any incoming request body that has a content type of application/JSON. Next, let's install this package called Morgan using npm-i-morgan. If you haven't already, the Morgan middleware is a simple but powerful tool that sits in your request response cycle and logs information about every incoming HTTP request. By calling app.use with Morgan with the argument dev in double quotes, you're telling Express to use this middleware. The string dev is a predefined format for the log output. It's one of several built-in formats provided by Morgan. The dev format is color-coded and concise, making it easy to read during development. We need to install the type as usual. Now, let's try out the Swagger docs to register a new user. Let's expand the post endpoint and click on Try It Out button. And we can see the schema object, which is editable, so we can create a name, email, and add a password. For the name, let's add test user. The email will be testuser@gmail.com. And the password will be test user password. And hit the execute button. We are getting a CORS error, so we have to install it by copying the npm install core from the npm site and pasting it in our terminal. Web browsers enforce a security policy called the same origin policy, which prevents a web page from making requests to a different domain. For example, a website at https://example.com cannot, by default, make an AJAX request to an API at https://api.myapp.com. This is done to prevent malicious websites from stealing data. The CORS middleware circumvents this policy in a controlled way by adding app.use with cors and 2 parentheses. Your Express server automatically adds the necessary HTTP headers to its responses, specifically the access control allow origin header. When a browser sees this header in a response from your API, it knows that the request is safe and allows it to proceed. Using cors with no options, as in our example, is a simple way to enable all cross-origin requests, which is common during development. For production, you can configure the middleware to only allow requests from specific domains to enhance security. Now that we have this fixed, let's move back and execute it again. And we get a response body which contains the token and user object, meaning our data was saved inside the database. At this point, you can verify it inside your database and see if it's there. So back to the MongoDB dashboard, we have the clusters menu under the database tab. Click on it and browse collections. Click on the test collection and open the user table. And at the bottom part here, we can see the user that was recently inserted. We can try and log in using the login endpoint on the docs page by entering the email and password used to register. And voila, we get a 200 OK response, meaning the request was successful and it returns a token. We can modify the email and see that we failed to log in. We get invalid credentials here, meaning the user authentication flow is working perfectly. Now inside the models directory, we are going to create a new file called blog.ts, just like we did for the user model. Let's start creating our Mongoose blog schema. This code will define the structure of our blog post documents in MongoDB. First, we'll import Mongoose and a few of its types like schema, document, model, and types. These are all crucial for working with Mongoose in TypeScript. Next, we'll define our iBlog interface. This interface extends the Mongoose document type and acts like a blueprint, telling us exactly what fields a blog post will have and what their types are. Now, we'll list the fields for our blog. We'll add a title, content, and an optional image URL, all of which are strings. We'll also include a special field for the author, and some timestamps. With our interface defined, we can now create the Mongoose schema. We'll create a constant called blog schema and initialize it as a new schema object. We'll pass our iBlog interface to it for type safety. Inside the schema, we'll define the properties and the rules. For our title, we'll make it a string, set required :true so it can't be empty, and add trim :true to automatically remove extra spaces. The content will also be a string and is required. The image URL is a string, but we'll leave it as optional since not all blog posts will have an image. This next field is important. The author is a schema.types.objectID. This tells Mongoose that this field will hold the unique ID of another document. We also add ref : user : to specify that this ID refers to a document in our user collection. We make it required and add an index : true to make searching by author much faster. Finally, we'll add timestamps : true. This is a great Mongoose option that will automatically add and update created at and updated at fields for us, saving us a lot of manual work. With our schema complete, we can create our blog model. This is the final step. It's what Mongoose uses to interact with our blogs collection in the database. We call mongoose.model and pass it the collection name and our blog schema. To make it easy to use this model in other files, we'll export it as the default export of this file as well. And that's it. We've created a complete, robust, and well-structured Mongoose schema for our blog posts. Now we can start interacting with our blogs collection in our application. This diagram illustrates exactly how a client's request flows through various stages and how middleware plays a crucial role in processing it. Let's break it down step by step. Everything starts here with the client's request. This is when a user, whether through their browser or a mobile app, sends a request to our server. Maybe they're trying to load a web page, log in, or submit a form. This request carries all the information our server needs, like the URL, HTTP method, and any data they're sending. Once that request hits our server, it immediately enters what we call the middleware chain. Think of middleware as a series of functions that can intercept, process, and even modify the request and response objects before they reach the final destination. First up, we have the logger middleware. As the name suggests, its primary job is to log information about the incoming request. This is incredibly useful for debugging and monitoring your application in development and production. It might log the request method, URL, and time. Next in line is the auth check middleware. This is where we handle authentication. It's like a security guard. Before the request can go any further, this middleware checks if the user is authenticated, perhaps by verifying a token. If the user isn't authorized, this middleware can stop the request right here and send back an error. Following that, we have the validation middleware. This middleware is responsible for checking the data sent by the client. For example, if a user is trying to create an account, this middleware ensures that the email address is in a valid format or that the password meets certain criteria. It prevents bad data from reaching our core application logic. After passing through all these middleware functions, we reach a critical decision point. Did any middleware fail? If a middleware function encountered an issue, like an invalid token in the auth check or bad data in the validation step, then the yes path is taken. This leads directly to an error response. The middleware sends an appropriate error status code and message back to the client, and the request stops its journey. However, if all middleware functions pass successfully, then the no path is taken. This means the request is deemed valid and secure enough to proceed to its actual purpose, the route handler. This is the specific function designed to fulfill that particular request, like creating a new user or fetching a list of blog posts. Once the request hits the route handler, it executes the business logic. This is where your application does its main work, interacting with the database, performing calculations, or integrating with other services. After the business logic is complete, assuming everything went well, it generates a success response. This is the data or confirmation that the client was expecting, along with a successful HTTP status code. Finally, this success response is sent back and the client receives response. The cycle is complete and the user gets the information or confirmation they were waiting for. Next, we are going to create the blog controller. But before we do that, let's create a middleware. First, we'll import the types we need from Express. Request, response, and next function. We also need to import the JWT library, which we'll use to verify our JSON web tokens. Now we'll create a new interface called auth request. This extends the standard Express request and adds a new optional field called user ID. We do this so we can attach the user's ID to the request object after we verify the token. Let's create our middleware function. We'll export a function called requireAuth that takes 3 arguments: a rec of type auth request, a res of type response, and next of type next function. The next function is what we'll call to move on to the next middleware in the chain. We'll start with a try block. All of our authentication logic will go in here, and we'll use a catch block to handle any errors. We need to get the user's authorization token from the request headers. We'll access the authorization header and store it in a constant called header. Next, we need to validate the header. We'll check if it exists or if it doesn't start with the word bearer. If either of these is true, we immediately send a 401 unauthorized response and return, which stops the request from going any further. If the header is valid, we'll extract the token. We use slice to get rid of the bearer part and then trim to remove any extra white space. Now, we need our secret key to verify the token. We'll store our JWT secret in a constant called secret. We then check if the secret is missing. If it is, we know we have a server-side problem and send back a 500 internal server error. This is the most important part. We call jwt.verify to validate the token. We pass in the token and the secret. This function will throw an error if the token is invalid or expired. If it's valid, it returns the original payload we signed, which we cast as an object with the user ID. Now that we know the user is who they say they are, we'll attach the user ID to our request object. This makes the user's ID available to all of our protected root handlers later on. Finally, we'll call next with parentheses to pass control to the next middleware function in the chain, which will be our root handler. If we don't call next, the request will just hang and never reach its destination. Now for the catch block, if jwt.verify threw an error for any reason, like a tampered token or an expired token, this block will run. We'll send a 401 unauthorized response with an invalid token message to the user. To finish, we'll export our requireAuth function as the default export, so it's easy to import in our root files, and that's our requireAuth middleware. It's a fundamental piece of any secure API, and you'll use it to protect all of your private routes. Now let's talk about handling image uploads. There are two main ways to do this, and one is much better than the other. The first is the by reference approach, which is the industry standard. When a client uploads an image, the API receives it and immediately sends it to an external storage service like AWS or Cloudinary. This service then returns a unique URL for that image. We then save the URL to our database and not the image itself. When our application needs to display the image later, it simply fetches the image by URL from the external storage. This is efficient because it keeps our database small and lets specialized services handle the heavy lifting of storing and serving large files. The second method is the inside database approach. Here, after the API receives the image, we convert it to binary data and then save the binary data to our database. This sounds simple, but it has major drawbacks. It can quickly make your database extremely large and slow down queries, which are not designed to handle huge binary files. When the application needs to show the image, it has to fetch the image from the database, which can be a very slow operation. In short, the by reference approach is the best practice for performance and scalability, while the inside database approach is generally avoided in production applications. Now that we have our middleware, let's go ahead and create a utility function for uploading a blog image on the app. We will create a file in the utils folder called uploader.ts. First, let's import the necessary libraries. We need Malta itself. We would have to install it using npm install Malta. We also need path for handling file paths and fs for interacting with our file system. Now, we'll create the directory where our files will be stored. We'll define the path to our uploads folder. And then use fs.exists_sync to check if it's there. If it's not, we'll use fs.mkdeasync to create the directory. This is a great practice to make sure our application always has a place to store files before it tries to save them. Next, we'll set up our storage configuration using multi-disk storage. We'll pass it an object with two key functions, destination and file name. The destination function tells Multa where to save the file on our disk. We'll simply call CB, which stands for callback, and pass null for no error, and then our upload directory. The file name function is a bit more involved. It determines what to call the file. We'll create a unique suffix using the current date and a random number to make sure every file has a unique name. We also grab the extension from the original file name. Finally, we call CB to return the new unique file name. Now let's add some validation. We'll create a function called imageFileFilter. This function will check the file's MAME type to make sure it's an image before it gets saved. If the MIME type starts with image slash, we call our callback with null for no error and true to accept the file. If it's not an image, we call the callback with an error to reject the file. Finally, we'll create our main Malta instance and export it. We pass it our storage configuration, the file filter function we just created, and we also add a limit object to restrict the file size to 5 megabytes. And to make this module easy to use, we'll export it as the default as well. And that's it. We now have a secure and reliable file uploader that saves to disk, validates the file type, and enforces a size limit. It's ready to be used in our API routes. First, we'll import our types from Express and our blog model. We also import our custom auth request type, which we'll need for our authenticated routes. Now, let's create our first function. createBlog is an async function that takes our auth request and response objects. We'll start with a try block to handle errors. Inside it, we'll destructure the title and content from the request body and check if they are missing. If so, we'll return a 400 error. Now we handle the image. We'll check if a file was uploaded using rec.file. If so, we'll create a URL for it. Otherwise, image URL will be undefined. Finally, we'll use our blog model to create a new blog post. We set the author field to rec.userid, which we got from our require auth middleware. This automatically links the blog to the authenticated user. We then return a 201 success message with the new blog. We'll close the try block and add a catch block to handle any unexpected errors. Next, we'll create our list blogs function. This one is simple. We just want to get all the blogs. We'll use blog.find to get all documents. The dot populate with author in double quotes, comma, name and email in double quotes is a mongoose feature that replaces the author's ID with the actual user document, so we can get the name and email directly. We also use dot sort with created at and the number -1 to display the newest blogs first. We return the array of blogs as a JSON response. We'll finish this function with its own catch block. Now for our getBlog function, we need to get a specific blog by its ID. We'll destructure the ID from the request parameters. Then we'll use blog.findById with the ID to find the blog. We also use .populate again to get the author's information. If the blog isn't found, we'll return a 400 for not found error. Otherwise, we'll return the blog. And a final catch block for this function. Our final function is update blog. This one is more complex because it includes a security check. We'll get the ID and find the blog just like before. If it doesn't exist, we return a 404. This is the security check. We compare the blog's author ID with the user ID from our request. If they don't match, we return a 403 forbidden error because the user is not allowed to modify this blog. Now for the update logic. We'll destructure the new title and content. We use a type of check to make sure they are strings before we update them on our blog object. We'll add a check for a new file upload. If a file exists, we'll update the image URL on our blog object with a new path. Finally, we use await blog.save to persist all our changes to the database. We use save here because we modified the document directly, and we'll close the function with a catch block. And that's it. We've successfully built all the controller functions for our blog API, complete with security checks and data handling. Now, I'm not going to implement the delete function of the blog. That will be a try on for you guys to work on. Next, we are going to work on the blog routes inside the blog route.ts file. First, we'll import the router from Express. Then we'll import all our blog controller functions. Create blog, list blogs, get blog, and update blog. We also need to import our require auth middleware and our upload middleware. Now, we'll create a new router instance by calling the router function. Let's start with our simple get route. The first one will get all blog posts. We'll use router.get, pass in the path / and then specify our list blogs function to handle the request. The next route will get a single blog post by its ID. We use a dynamic parameter here, a colon followed by a name, so we can capture the ID from the URL. So we type /:ID and connect it to our get blog function. Now, for the more complex routes, this post route will create a new blog. We'll use router.post with the path /, but before we connect it to our create blog function, we'll add our middleware. The first middleware is require auth. This is our gatekeeper. It will check for a valid JWT token in the request headers. If the user is not authenticated, the request stops here. Only if the user is authenticated does the request get passed to the next middleware. The next middleware is upload.single with image in double quotes. This comes from the Multa library we configured. It tells Multa to expect a single file in the request body with the field name image. Multa will process the file and then attach the file object to the request. Only after the file has been processed does the request continue. And finally, we have our controller. Once the user has been authenticated and the file has been uploaded, the request is passed to our createBlog function, which can now access rec.userid and rec.file. Our final route is for updating a blog. We use router.patch to handle a partial update. We'll add the same middleware chain as our create route with require auth and upload, and then connect it to our update blog function. Finally, we'll export our router as the default export of this file, so we can use it in our main application. And that's our complete blog router. We've successfully set up our routes and a powerful middleware chain to handle authentication and file uploads. Alright, let's add the Open API documentation to our blog routes. This will provide a beautiful interactive page in Swagger UI for us to test and understand our API. We'll start with the simplest endpoint, listing all blogs. First, we'll open a multi-line JSDoc comment. Inside, we will add the @API tag and define the path /API/blogs with the method get. Next, we'll add a summary to give a short description of what the endpoint does and a tags property to group it under blogs in our documentation. Finally, we document the possible responses. This endpoint simply returns a 200 OK status. Now, let's document getting a single blog by its ID. We'll start with the same tags, but the path will be /API/blogs/curly brace ID curly brace. Because the ID is part of the URL path, we need to define it with the parameters section. We specify its location within :path, its name as ID that it's required, and its schema type as a string. This endpoint can return a 200 OK if the blog is found, or a 404 not found if it isn't. This next endpoint is more complex. It's for creating a new blog and requires a logged in user and a file upload. We start with the post method for the path /API/blogs. Because this route is protected, we add a security section and specify our bearer auth security scheme. This tells Swagger to include a lock icon on this endpoint in the UI. For the request body, we specify that it's multipart /form data because we are accepting a file. The schema defines the properties: title, content, and image. For the image, we specify its format as binary, which is how Swagger knows to include a file uploader. And for the responses, we expect a 201 created on success and a 401 unauthorized if the user's token is missing or invalid. Our final endpoint is for updating a blog. It's similar to the previous one, but with a patch method and an ID parameter in the URL. We'll add the same parameter section for the ID from the path. For the request body, we set required :false because the user might not update every field at once. We also remove the required array from the schema. Finally, we define the responses. We have 200 OK for a successful update, 401 unauthorized for an invalid token, and a new one, 403 forbidden if the user tries to update a blog that isn't their own. And there you have it. Our API routes are now fully documented for Swagger. This is the last step before we can see our interactive API documentation in the browser. Now back to the index.ts file. We are going to add the blog route using the same method as the auth route. The line app.use with /API/blogs in double quotes and blog routes tells your Express application to use the blog routes router whenever a request URL path begins with /API/blogs. Alright, all the routes defined inside blog routes like / for listing all blogs or /:id for a specific one will be appended to this base path. For example, a request to / in your blog routes file will be handled at the full URL path of /API/blogs. A request to /:id in your blog routes file will be handled at /API/blogs/:id. The second argument, blog routes, is the router you created in your blog route file. This is the router that contains all of your blog specific endpoints. By passing it to app.use, you are instructing Express to use it as a middleware handler for any requests that match the base path. This is a common and recommended way to structure a large API with many different resources. We need to import the blog route to make this work. Now let's test the blog router on the Swagger docs API key. We are back on the Swagger docs. Let's log in, copy the token, and add it to the authentication of Swagger, and then use it to create a new blog. Let's log in with these credentials. These are the credentials of the user we created earlier. Hit the execute button. We have a successful login. We will then go ahead and copy the bearer token. Scroll up and on the authorize button on the far right, we will paste our bearer token. Authorize and close it. Next, let's create a blog. We will click on the try it out button and fill the form accordingly. Here we will enter the title to be my first blog post, and the content to be my first blog content. And choose a file for the blog post. And voila, we have a 200 response status from the server and a response body, which contains the blog title, content, image URL, the image is saved as a reference, the author ID, and the date it was created. Awesome. When we move back to the code, we will see inside the uploads directory the new image that was uploaded. We can copy the blog ID and get a single blog like this, returning a response body as it is supposed to do. Glad this is working perfectly fine. To edit a blog, you just need the ID, paste the ID here, and add the updated title and content of the blog. And hit the execute button, and we can see the edited title and content. Awesome. Give a pat on your back if you have made it this far. Every app needs to be tested. And I mean, without testing, how do you even know if the code you wrote can withstand any test cases in the real world? Traditional testing tools are not comprehensive, and now, in the new AI era, we need a comprehensive testing tool. That is where testSpirit comes in. testSpirit is an AI-powered platform that automates the entire software testing process, from generating test plans to executing tests and analyzing results. By interpreting natural language documentation, it creates comprehensive test cases and runs them in a cloud environment, providing detailed reports to enhance debugging and improve software quality. To set up testSpirit, visit the website which I have linked in the description. Let's click on the docs link in the nav bar. Over here, under the Get Started tab, we have the installation section. On the installation page, you first have to be on the Cursor AI Code Editor or VS Code. Luckily, we already have this set up correctly. The next step will be to sign up for free. After signing up, you'll be shown this modal. Upon clicking Got It, we have two buttons here. One says Go to Dashboard and the other says Test Locally. We will next click on the Test Locally MCP button. Now, a clean and easy setup process on how to use testSpirit MCP is shown. The first step is to generate an API key. We will skip that and do it later, if not sooner, and add testSpirit to our cursor by clicking on the Add to Cursor button. We do have other options like Cloud Code and other IDEs, but we will go for cursor. Upon clicking on the button, we will be prompted to open our cursor app, where we will be taken to the MCP and interpretation page. We'll scroll a little bit down. We see testSpirit over here with a command and an environment variable with an API key. To generate the API key, we will move back to the testSpirit dashboard and generate one. You can give the API name any name of your choice though. I choose to name mine Blog API. Now copy this API key, which you can't get access to again after closing this modal. Copy the API key and click on Done. Back to the cursor app, we add the API key to the API key variable over here and install. For a while, testSpirit will install everything and get everything going and ready. These are the packages that were installed by testSpirit to help us generate test cases for our app. Now back to the dashboard for testSpirit, we are going to copy this magic command to kickstart our testing. It is as easy as that. Hitting Command +I to open the composer and pasting in the magic command, "Hey, help me to test this project with testSpirit." We wait and sit back for the AI to do its magic. We can see a couple of thought processes going on here, and over here I mean where we have the bootstrap testSpirit with appropriate configuration. It will open a browser for you to make some manual configuration, and then the process will continue. On this page or configuration page, we will select the mode and scope, and since this is an API, we will leave everything to backend and make the scope the entire code base. Next, we will choose the authentication type, which is bearer token authentication, and add the token. To get the token, we will visit the docs page for the Swagger API docs and log in all over again and get the token. Copy it and paste it inside the credentials. We'll configure the port, which is 3000, so we will leave it like that. One more important thing is the product specification docs, which when you check the GitHub repo, you will find over there. Inside the root directory, there will be a prd.md file. I will elaborate more on this soon, so let's upload the prd file and continue. Now, to generate the PRD for yourself, you can use the prompt over here. Generate a PRD for me based on the project. The PRD is like the blueprint and contains all the details needed to bring your app to life. So over here, when we open it, we can see the project overview, executive summaries, goal, and primary users, and all other details. Now, all we have to do is wait for the test to be completed. I will skip this part and continue when it's done. Now it seems to be done and all tests are completed. So when we check our project directory, we can see a new folder called testSpirit tests, and inside it we have a couple of folders and files which contain the reports, prompts, and other details that may be of your interest. But to get a clean look at what testSpirit tested, we will go to the dashboard, and on the MCP tests section, we can see all the test results here. We had 6 out of 10 pass, so let's look through. User registration passed, user registration with missing data passed, user registration with duplicate email passed, but we failed at user logging in with valid credentials. So let's click on that and see what actually happened. Looking at the code, everything is right. The base URL, login endpoint and token, and also the headers. And when we tested it manually, it worked. So let's try and rerun the test after a prompt modification. Let's type login is right. Can you rewrite the test? We wait for it to finish and move back to the dashboard. On the dashboard, we now have 7 passes, but the login with valid credentials still isn't working. And these things are bound to happen since the tests are generated by AI. There might be some errors here and there, so to fix all the tests to get a 10 out of 10 pass, you just have to re-prompt the AI and ask them to fix issues with why the test is not passing, and it will come out clean. Since we have already exceeded the length of how I envisioned this video to be, I will leave that for you as a work to try. Work on it and tag me on Twitter or put it in the comment section with your overall experience. Now let's test the blog router on the Swagger Docs API key. We are back on the Swagger Docs. Let's log in, copy the token, and add it to the authentication of Swagger, and then use it to create a new blog. Let's log in with these credentials. These are the credentials of the user we created earlier. Hit the execute button. We have a successful login. We will then go ahead and copy the bearer token. Scroll up and on the authorize button on the far right, we will paste our bearer token. Authorize and close it. Next, let's create a blog. We will click on the try it out button and fill the form accordingly. Here we will enter the title to be my first blog post, and the content to be my first blog content. And choose a file for the blog post. And voila, we have a 200 response status from the server and a response body, which contains the blog title, content, image URL, the image is saved as a reference, the author ID, and the date it was created. Awesome. When we move back to the code, we will see inside the uploads directory the new image that was uploaded. You can copy the blog ID and get a single blog like this, returning a response body as it is supposed to do. Glad this is working perfectly fine. To edit a blog, you just need the ID, paste the ID here, and add the updated title and content of the blog. And hit the execute button, and we can see the edited title and content. Awesome. Give a pat on your back if you have made it this far. It's been an incredible journey, and I hope you learned a lot. If you haven't subscribed, kindly do that, and I will see you in the next one.